As a first-year solar car team, we were very happy with our results in the 2019 Solar Car Challenge. Our team of 6 core members brought our car to Texas to compete, where we placed second in the Classic Division. We also won one race day and brought home the Lockheed Martin Engineering Excellence Award, as well as the Telemetry Award. As a small club, we decided the best course of action was to spend the 2019 to 2020 school year working to grow our club and solidify our presence in the community. We started the year off in a rough place, already in some minor debt from the year before. Undaunted by this, we began recruiting club members on our Instagram and YouTube and via word of mouth. After bringing home our trophies, we were interviewed on some local news channels, as well as personally congratulated in a town hall meeting. All of these events brought more publicity to our club, and within several weeks of school starting, we already had amassed 60 members.
From here, our club split into 3 main focuses. These included fundraising, building, and planning. Our team of business people got to work reaching out to current sponsors for continued support, as well as finding other businesses that would be interested in contributing. Our build team made the decision to modify the car we had and made improvements to it for the following year, so that our team could simultaneously begin the process of researching and designing an advanced car for the following year.
For the team build, the main focuses were making minor adjustments to accommodate for rule changes, as well as trying to improve aerodynamic efficiency. We reached out to our largest sponsor, AVL, an engineering company, and talked to them about how to best find ways to improve our aerodynamic efficiency. As the CAD team got to work running simulations, our mechanical team took a look at improving the most obvious design inefficiencies. These included redesigning the shape of the windshield and fixing the stacking effect on our panels. In order to reshape the windshield design, the mechanical team began debating and discussing what they thought would be their best solutions. Eventually, the team had come to a split decision between 2 main designs and found a way, with the help of a math teacher in our school, Mr. Pline, to test the windshield models. Both teams got to work making scale models of the windshield. When these designs were completed, they secured them to a large fan via spring scale that could graph the forces in newtons. They lined up both models and turned the fans on, and found one model significantly outperformed the other in terms of efficiency. They then researched new windshield materials and ordered what they needed to begin fabricating their design.
In the meantime, another group of mechanical students had managed to successfully work out our issues with panel stacking by finding a willing sponsor in China able to create custom manufactured panels to our requirements. In order to fund all of these different projects, we needed a new way of raising money. We were seriously slowing down in terms of donation from local businesses, and if we were to begin making purchases for things like new panels, we needed to raise more money. After many successful bake sales, our business team carefully planned a thorough can and bottle drive that would have us reach every house in our district in an attempt to collect as many bottles as we could. After several meetings of sectioning off nearby neighborhoods and figuring out what students could drive others, we began printing thousands of pamphlets on the school printers to distribute. Our team of 60 students, assembled along with another 30 volunteers, began distributing flyers to their respective areas.
After only one cold weekend of flyer distribution, our entire district was covered. In hindsight, having my personal phone number available on our website may have been a mistake, as in the coming days I received dozens of calls and texts from people giving everything from encouragement to cash donations. The following week, our entire team of students and volunteers assembled in the school parking lot. Hundreds of garbage bags were distributed, and underclassmen all found upperclassmen that could drive to partner up with.
Over the course of one day, all of our district's cans and bottles were collected and shuttled to our captain, Eric's garage, which was quite literally filled by the end of it. Eric and his family, along with several other club members, slowly deposited these cans and bottles to the local return centers over the coming weeks and raised well over $1,000 in recycling alone. Needless to say, our recycling and fundraising efforts got us even more attention, which led to more donations from the community on our website and more students joining our club.
Around this time in late January, we began to finalize our modifications to the car. The solar panels had been ordered and the focus had shifted to planning our next car to compete in the advanced division. We began consulting with other experts in the field, including engineering students and professors at our local university, Michigan State. Our CAD designs were underway with the design inspired by a combination of the Roz Clean Energy Team's car and Covenant Christian's car. Our lithium-ion batteries were selected, as were our panels and hub motor.
Our telemetry system also got a lot of focus this year. We held multiple workshops for those interested in contributing to the telemetry system, where we went over the basics of coding and wiring, as well as a walkthrough of our current system. While some students began adding a plethora of sensors to the car, including panel and battery temperatures, as well as live panel wattage, others began working on the data transmission system. In preparation of the upcoming road race, we decided to add in LoRa antennas as well as our current cellular setup, so that there was a failsafe in place and we would never miss a data stream.
In our last race, our live telemetry data was analyzed to find our efficiency and keep it as high as possible while remaining competitive. We also had someone periodically checking weather conditions and cloud cover to anticipate changes. This year, we removed that system entirely. After reverse engineering how our throttle works, we found it was essentially a glorified potentiometer and could be controlled with an Arduino. Our new goal became for the driver to act as the steering system and braking system, and to let the car, controlled by its telemetry system, control the acceleration. After collecting every data point we had, we came up with a rough idea of how we wanted to calculate the optimal speed.
Using all of our sensor data, GPS information that could tell us when hills were near, and a weather API that gave us access to the Texas Motor Speedway's weather hub to determine real-time and predicted cloud cover, we put all of these together to generate a rough algorithm to keep the car at the ideal speed when the driver turned on cruise control. Unfortunately, as our solar panel order in China was put on hold due to the coronavirus over there, we eventually were shut down due to the virus as well. Our school closed in March with the expectation that we'd be gone for only a small amount of time. This meant we hadn't taken any resources from the school to work on independently, and we have been unable to access the car since. Our advanced car plans are fairly solidified as we have had used the time to make some small adjustments to them. We also have found more local sponsors and built up a sizable sum in club funds to spend on the building of our future advanced car.
Our telemetry team has also spent much of its time this summer modifying and tweaking our cruise control algorithm. They are in the process of developing a custom program that will pass simulated data to a machine learning artificial intelligence program they have been working on. Their hope is that we will be able to have a computer write our cruise control algorithm for us, with every possible data point being used as optimally as possible.
Thanks for listening, and we hope to see you all next summer. Go Chiefs!